Assalamu alaikum, everyone. Welcome to Mathematics with Shahab Yaqub. So, this is the second part of the review of integration, and it's about volume of revolution. The focus is on topical past papers of T1. Now, let's look at this question. It's about volume. The question says, let me start underlining it. The question says the diagram shows part of the curve. Now focus on this. X is already the subject. The equation of the curve is written right over here. So let me highlight this. That is the equation of the curve. Let me make it thinner. Just hold for a second. So that is the equation of the curve. X is already the subject. Now it says the shaded region is bounded by the curve. That is the shaded region. This is bounded by the curve and the y-axis and the lines y is equals to 1 and y is equals to 2. This is the line y is equals to 1. This is a line y is equals to 2. Showing all necessary working. That means show every single step. Find the volume in terms of pi when the shaded region is rotated 360 degrees about the y-axis. So the rotation, it's about y-axis. What is the rule? The rule is volume of revolution. There is pi. There is limits q and r. Function should be in terms of y, the whole thing square, and don't forget to write dy over here. Now, the steps are pretty simple. That is first square. Then naturally, you have to integrate. You have to plug in the limit. Don't forget to multiply by pi. Now, since it's being revolved around the y-axis, x should be the subject, which is already the case. Now, the very first thing that I'll do on the sidelines is that x is 12 over y square minus 2. Let me square it. So 12 over y square minus 2, the whole thing square, it's a binomial. It's a minus b whole square. That is 12 over y square square. This is minus 2ab. That's 2 into 12 over y square into 2. This negative is already considered, plus 2 square. So let me simplify all these terms. That is 144 over y square. 2 into 2 into 12. That's 4 into 12, which is 48 over y square. And this is 2 square, which is 4. And rewrite this thing as 144 y raised to power of negative 2. Actually, it's 4. My bad, I just corrected it. And this is 48 y raised to power of negative 2. And this is 4. This is the squaring part. Now, for volume of revolution, I'll write volume is pi. What are the limits? The limits are on the y-axis, which is 1 and 2. So this is 1, this is 2. This is function in terms of y, which is 12 over y square minus 2 whole square dy. The squaring and the simplification is already done on the sidelines. So that is pi. This is 1 till 2. This is 144 y raised to power of negative 4. This is 48 y raised to power of negative 2. And this is plus 4 dy. So the squaring is already done. Now, the next step is actually integrating it. So pi remains as it is. And this is integration 144 y raised to power of negative 4 plus 1 over negative 4 plus 1 minus as it is 48 raised to y raised to power of negative 2 plus 1, negative 2 plus 1, and 4 after integration becomes 4y. Now keep in mind, first simplify, then plug in the limits. So this is pi. This is 144 raised to power of negative 3, and negative 3 is downstairs. This is minus 48 y raised to power of negative 1. Negative 1 is downstairs. Downstairs means the denominator. And this is 4y between 1 and 2. Now, is 144 divisible by 3? I think so. So 144 divided by 3, 150 divided by 3 is 50 and then 6. So this is 48. So this is 48. So therefore, this is pi. This is negative 48. And I think I missed out the y. So let me write the y over here. So this is 144 y raised to power of negative 3. So 48 and then y raised to power of 3 goes down. This negative makes it positive. That is 48 over y. And this is 4y as it is. And this is 1 and this is 2. So there are two terms with a positive sign and one term with a negative sign. Just have a good look. Just double check if everything is all good, all clear. Now let's go through the steps once again. X is already the subject. If it was not the subject, we will make it the subject. Second thing, the squaring for this part was done on the sidelines. The simplification was done and then it's inserted over here. This purple step, this is about integration. The next purple step, this is about simplification. Now, after the simplification is done, we take this thing down, and now it's in a position that we can plug in the limits. So let's plug in the limits. That is pi as it is. And let me just work a little bit leftwards. This is pi as it is. First the upper limit, then the lower limit, then this bracket. So let me plug in 2. That is minus 48 over 2 cube. This is 48 over 2. This is 4 times 2. Let's plug in the lower limit, which is 1. So this is minus 48 over 1 cube, which is 1. This is 48 over 1. This is 4 times 1. Now let's do some cancellation. This is negative 48. This is positive 48. It will cancel out. So 4 remains and there is a minus sign on the outside. And this is negative 48 over 2 cube. 2 cube is 8. So 48 over 8 is 6 with a negative sign. 48 over 2, that is positive 24. 4 into 2, that is 8. And there is a pi on the outside, minus sign, and 4 into 1 is 4. So that 4 is there. Now let's simplify it further. So how many positives do we see? We see a 24, we see an 8, that is 32. Minus 4 minus 6 is negative 10. 32 minus 10 is 22. So the answer is 22 pi units cube. So if all thing is set, this should be the answer. So that is the answer for this part. This is some extra page and that is the answer, which is 22 pi. Now just look at the mark scheme. They haven't put in much effort except for the fact that they did the integration and that's it. Limits 1 to 2 used and all this hard work that I have put in, that is what is required by the examiner. You'll be getting marks on this. It's worth 5 marks. So every single step is necessary. So now this question is done. Let's move to the next question. Have a good look at it. Just go through it. Now, let me just double check one thing. That is, yes, the voice is on and the recording is on. All good, all clear. So once you have read it, now I'll underline this thing. So the first question was about with the y-axis. Now let's say which question is this. Now it says the diagram shows part of the curve. It's not the full curve, it's part of the curve. And the equation of this curve is this thing. Y is equals to this thing raised to power of half. Now it says, and the point P lying on the curve. So P is on the curve. Find showing all necessary working. The volume obtained when shaded region is rotated 360 degrees about the x-axis. So always be in a habit of showing through which axis that you are moving it. You are revolving it. Volume of revolution. Now that's the equation. Y is the subject, perfect. And the limits are, this is 0, this is 2, that's limit. And this is simple volume. It's all the way till the x-axis. So now I'll write volume, that is pi. The limits are 0 and 2. The equation is x cubed plus 1 raised to power of half. The whole thing square dx. Is the step clear? It already has a half on this thing. After squaring, it would cancel out and life will become easy. That's why it's worth only 4 marks. So this is pi. This is 0, this is 2, this is x cubed plus 1, this is power 1 dx. Now a question, that is, can I apply chain rule? I cannot apply chain rule. The reason being, let me write it down. So over here, chain rule is not applicable. Chain rule of integration is n/a, not applicable. Why? Because chain rule is only applicable if it's a linear expression. The power is n. So there are 2 limitations. Let me first write it down. Ax plus b, n plus 1, divide by the new power, divide by the coefficient of x plus a constant term. It's the limitations are ax plus b, only linear. That is the thing. The second thing, that's not an issue over here, but it can be later. And of course, that won't be asked in P1. That is, n could be any power except n should not equal to -1. So right now, you have to integrate it individually. So this is pi. This is x cubed over x power 4. So this is 3 plus 1 divided by 3 plus 1, and 1 becomes x between the limits 0 and 2. 0 and 2. So this is pi. This is x power 4 over 4 plus x between 0 and 2. Now let's plug in the upper limit. So that is 2 power 4 over 4 plus 2. Close the bracket. Let's plug in the lower limit. That is 0 power 4 over 4 plus 0. There is a minus sign in the middle. There is a square bracket. There is a pi on the outside. There is equal sign. 2 power 4 is 16. 16 over 4 is 4. 4 plus 2 is 6. So this is 6 pi because this whole thing is 0. Let's double check the answer. So the answer is 6 pi. Do not simplify it further. Leave answer in exact form in terms of pi. So that is all good, all clear. So 2 questions are down. One was with the y-axis, the other one was with the x-axis. So now let's look at this particular question. It says the diagram shows part of the curve. Find the equation of normal to the curve. So it's a combination of differentiation and integration at the point where x is equals to 1 in this particular format. So let me highlight this. The first thing, find equation of normal to the curve at the point where x is equals to 1. What is the format? Y is equals to mx plus c, where m and c are constants, and it's for 5 marks. So now first thing first, that is y is equals to 4 bracket 5 minus 3x raised to power of -1. dy by dx, differentiate 4 as it is. -1 comes down. 5 minus 3x, power becomes -2. Don't forget to multiply by derivative of bracket, which is -3. So now we have -1, we have -3, that is positive 3. 3 into 4 is 12. So this is 12 over 5 minus 3x, the whole thing square. Now let's plug in x is equals to 1. Let x equals to 1. Let doesn't seem nice. So plug in x is equals to 1 in dy by dx. So therefore dy by dx is equals to 12 over 5 minus 3 into 1 whole square. 5 minus 3 is 2. 2 square is 4. 12 over 4, which comes out to be 3. Gradient of tangent is positive 3. Gradient of normal is negative 1/3, negative reciprocal. And when x is 1, I need y. So when x is 1, y is 4 over 5 minus 3 into 1. That is 4 over 5 minus 3 is 2, which comes out to be 2. So the coordinate is 1, 2. So 1, 2. Therefore, equation of normal, that is what we are working for. So for equation of normal, so it's not formal, it's normal. Y minus y1, I can use this and then I can get it in that format, is equals to mx minus x1. Y minus 2 is equals to negative 1/3 x minus 1. That is negative 1/3 x plus 1/3 plus 2. So this is negative 1/3 x and 2 and 1/3. That is 7 over 3. So this is 7 over 3. And this is in the form y is equals to mx plus c. Y is equals to mx plus c. They are not asking us to state the value of m and c. If they would have, we would say that m is negative 1/3, c is 7/3. So let me first double check the answer for this one. So y is equals to, there it is, y is equals to negative 1/3 x plus 7 over 3. So alhamdulillah, we got it correct. Now the next part, that is the shaded region. The shaded region is bounded by the curve, the coordinate x's and x is equals to 1. So this is simple area. It's under the curve all the way till the x-axis, and we are revolving it around the x-axis. Find, showing all necessary working, the volume obtained when the shaded region between 0 and 1 is rotated through 360 degrees about the x-axis. 4 over 5 minus 3x. So let me write over here. Y is equals to 4 over 5 minus 3x. So volume of revolution, volume, that is pi. This is second part. That is pi. Limits. The limits are, this is 0, this is 1. This is 0, this is 1. This is 4 over 5 minus 3x. The whole thing square dx. First square, 0, 1, 16, 5 minus 3x, the whole thing square dx. Now take the 16 on the outside. That is 16 pi, 0, 1. This is 5 minus 3x raised to power of negative 2 dx. This is 16 pi. And now let's integrate. This is 5 minus 3x, negative 2 plus 1. Negative 2 plus 1. Derivative of bracket is negative 3 between the limits 0 and 1. Now, a word of caution. So let me just write over here. That is two things. One thing is this thing. That is this one. Do not expand bracket in denominator. That is the first thing. And of course, related to this, that is a chain rule is applicable. So basically, chain rule is applicable, and that is how you have to integrate it. All good, all clear? So now simplify it a bit more. This is 16 pi. Negative 2 plus 1 is negative 1. Negative 1 into negative 3, that's positive 3. Take this 3 on the outside. Simplify. Minus 2 plus 1 is negative 1. Therefore, it's written as 1 over 5 minus 3x between the limits 0 and 1. So this is 16 pi over 3. 1 over 5 minus 3 into something, minus 1 over 5 minus 3 into something else. Bracket, bracket. Now, this is the upper limit 1, write 1 over here. This is the upper limit 0, write 0 over here. So now this thing, the denominator 5 minus 3 becomes 2. and 5 minus 0 is 5. So therefore, we are left with 16 pi over 3. This is 1 over 2 minus 1 over 5. So 1 over 2 minus 1 over 5, that's the same thing as 5 over 10 minus this is 2 over 10. So 5 over 10 is half, 2 over 10 is 1/5, all good. That comes out to be 3 over 10. So this is 16 pi over 3 into 3 over 10. The 3 slashes off, and 2 8s are, 2 5s are. Therefore, this is 8 over 5 pi units cube or cubic units. Let's double check. 8 pi over 5, yes. And it's all good, all clear. So that is the working for this particular question. Now, let's look at this particular question. We solved something like this in class. Let me pause the recording. I would like you people to try this out. So first, I'm pausing the recording. So now let's look at this question. Now, the reason why I wrote try out and for 7 minutes max, because the rule is whatever is the number of marks, when you are in the practice mode, the number of marks should equal the number of minutes. When you will target for this, things will get easy for you in the exam. In the exam, the ratio is that of 1.5. That means marks, multiply it with 1.5, that equals number of minutes. That's the maximum thing. So now it says the diagram shows, let me highlight this. The diagram shows the straight line x plus y is equals to 5. Intersecting the curve y is equals to 4 over x at the point A 1, 4 and B 4, 1. Now, let's say if they had more marks, they would have made it solve simultaneously and given us maybe like 2-3 marks more. Find, showing all necessary working, the volume obtained when the shaded region is rotated 360 degrees about the x-axis. Now, first of all, if I focus on the line, so there is a region below the line. Then if I focus on the curve, there is region below the curve. And we are interested in the region that is between the line and the curve. So basically, we are looking for this particular region, which is already shaded in the diagram. And this is double shading that I've done. So now let me just remove it. It looks messy. So now I need the volume produced by the line. So volume produced by the line. And I need volume produced by the curve. And I'll subtract it. Now for the line, it's already, the equation is given. And let me make y the subject, which is 5 minus x. And it's between these two limits, which is 1 and which is 4. So basically, this one over here that I'm labeling, this is 1. This one over here, that's 4. So these are the two limits for both the things. So volume of the line, that is pi between the limit 1 and 4. And this is 5 minus x dx. And don't forget the square. Similarly, volume produced by the curve, that is pi between the limits 1 and 4. And the equation of the curve is 4 over x. Don't forget the square dx. So take all your time and think about these things first. Y is equals to 5 minus x. We have to square. This is 4 over x. We have to square. The limits are 1 and 4. The limits are 1 and 4. That's common limits. Don't forget pi. Now, this can be done using chain rule. This cannot be done using chain rule because this is not linear. So you have to expand it. So let me start with the blue thing. That is pi. This is 1. This is 4. This is 16. This is x squared dx. And then this is pi. This is, let me also take the 16 on the outside. So 16 pi, limits 1 and 4. This is x raised to power of negative 2 dx. This is 16 pi x raised to power of negative 2 plus 1, negative 2 plus 1, and the limits are 1 and 4. Simplify it a bit more. That is negative 16 pi. This is 1 over x between the limits 1 and 4. Now, the rule is if there is a negative sign over here, I want to remove it. I'll change the places of the limits. So that is plus 16 pi. This is 1 over x. 4 goes down, 1 goes up. Now, let's simplify. So therefore, this is 16 pi. This is 1 over 1 minus 1 over 4. 1 minus 1/4 is 3/4. So 16 pi into 3/4. That comes out to be 12 pi units cube. So that is area produced by that is the volume produced by the curve. That thing is done. What about the line? So therefore, this is pi. This is, I can apply the integration directly. So this is 5 minus x raised to power of 2 plus 1 is 3 divided by 3. Coefficient of x is negative 1 between the limits 1 and 4. So therefore, this is negative pi by 3. This is 5 minus x, the whole thing cube between limits 1 and 4. Again, what I can do is that I can get rid of this negative sign. I can change the places. It's not necessary. It just is better. So this is pi by 3. This is 5 minus x, the whole thing cube. And the limits are what? 4 goes down, 1 goes up. So this is pi by 3. This is 5 minus 1 cube. This is 5 minus 4 cube. So 5 minus 1 is 4. 4 cube is 64. 5 minus 4 is 1. 1 cube is 1. So this is 64 minus 1. This is pi by 3. This is pi by 3 of 63. 63 divided by 3, that is 21 pi units cube. Now the volume under the line is greater. The volume under the curve is lesser, which is naturally correct because the line is higher. It produces more volume. The curve is lower. It produces lesser volume. We want this thing in the middle. We want the difference. So therefore, the area, not the area, it's volume. Volume produced by the shaded, that is volume produced by the line minus volume produced by the curve, that is 21 minus 12. I have taken pi common out. That comes out to be 9 pi cubic units. You can write units cube. You can write cubic units. Let's double check, and that is over here. So this is all good, all clear. So now let's look at this particular question. First read it. I'll solve. Figure 1 shows part of the curve and the line y is equals to h. So this is the line y is equals to h. This is part of the curve. The curve would be going like this because it's a quadratic curve. The shaded region is rotated 360 degrees about y-axis. So let me focus over here. It's about y-axis. Show that the volume of revolution is given by such and such. So now, first of all, x can be made the subject. So x square is y plus 1, and there is no need of square rooting because anyway, for volume, we need the square. So therefore, volume of revolution between 0 and between h. So that between 0 and h, and it's already squared, which is y plus 1 dy. All good, all clear? And then we'll be plugging in the limits. So now let's integrate it individually because that's how the answer feels like. So this is pi. This is y square over 2 plus y between the limits 0 and h. Now let me plug in the upper limit, volume, pi. When I plug in h, that's h square over 2 plus h. Minus when I plug in 0, that is 0 square over 2 plus 0, close the bracket. So therefore, this comes out to be volume. That is pi. This is half h square plus h. That is exactly what's written over here for 3 marks. Now, it's also asking for area of the shaded region. For area of the shaded area under the curve all the way with the y-axis. So now this thing is part 1, that is volume. And in the same question, they are asking about area. So area is basic integration. The limits are again 0 in h. And this time, x has to be the subject. That is square root of y plus 1 or y plus 1 raised to power of half. So this is y plus 1 raised to power of half dy. And there is no pi. So this is y plus 1. Half plus 1 is 3 over 2 divided by 3 over 2 divided by coefficient of y, which is 1, between the limits 0 and h. So division by 3 over 2 is multiplication by 2/3. This is y plus 1, 3 over 2, and the limits are 0 and h. So this is 2/3. This is h plus 1, 3 over 2 minus 0 plus 1, 3 over 2. And this is 0 plus 1 is 1. So this is 2/3 h plus 1, 3 over 2 minus 1. We can leave the answer in this form. Now, the answer might look different. No, actually, that's the only way. It's not a matter of different, because if it was a power of 1, I could have integrated it in individual terms, but that's no other way except for chain rule. So let's double check this answer. So this one is this thing. The first thing is this thing. That is this one. That was done. The second one is this one, 10 part 2. And are they plugging in the values? I think they have given us the values. Let me double check. So now in part 2, it says when h is equals to 3. So actually, what I did is that I got the answer in terms of h. Now plug in. Now plug in. Plug h is equals to 3. So I worked in terms of this. So this is area. So area is 2/3, 3 plus 1 raised to power of 3 over 2 minus 1. That's 2/3. 3 plus 1 is 4 raised to power of 3 over 2 minus 1. Now a little bit of indices over here. 4 raised to power of 3 over 2 can be written as 4 raised to power of half raised to power of 3. That is 2 raised to power of 3, which is 8. So this is 2/3. 8 minus 1, which is 7. 7 twos are 14. That's 14 over 3. And that can also be written as 4 2/3. 3 fours are 12. 12 plus 2 is 14. Something like this. And this is unit square. That is the answer. So this is 14 over 3. That's right over here. And that is the answer. All good, all clear. Now, this one is something else. This is differentiation. Let's also solve this one out. So now it says figure 2 shows the cross section of a bowl containing water. Let me highlight this. And when the height of the water level is h, the volume of water is given by such and such. So it's the same volume that they are using from before. So that is volume is this. Water is poured into the bowl at a constant rate of 2 centimeter cube per second. Find the rate in centimeter per second at which the height of the water level is increasing when the height of the water level is 3 centimeter. Now, first of all, what we need to do, we have 3 variables. That is volume, and then there is height, and then there is time. So how is height and time related? That is dh by dt. That is what they're asking. How is volume and height related? That is dv by dh. In other words, how is volume and time linked? That is dv by dt. So if I write this, I'll write dv by dt equals to dv by dh. That is dv by dh into dh by dt. Now, what do we have? This thing over here, and let me just remove all this highlighting. So I'm just removing this thing, this thing, this thing. So now, first of all, dv by dt, how is volume changing with respect to time? That is this thing. So this is 2 centimeter cube per second. That is this thing over here. And then we have v in terms of h. So we have v in terms of h. If I differentiate this thing, I'll get this thing and I'll plug in the value of h is equals to 3. So let me first solve this. So volume is pi, that's a constant, half h square plus h. Therefore, dv by dh, pi as it is, half h square becomes 2h over 2, which is simply h, and derivative of h is 1. Now, when h is 3, therefore dv by dh is pi bracket 3 plus 1, which comes out to be 4 pi. So now I have this value, which is 4 pi. The green value over here is 2. And what am I looking for? I am looking for dh by dt. So basically, dh by dt is 2 over 4 pi, which comes out to be 1 over 2 pi. Leave the answer as it is, and it is centimeters, and it's second. So centimeters per second, that's the answer. Let's double check. So this is 1 over 2 pi. Do not write in decimals because exact form is beautiful. You don't have to worry about accuracy. So exact form is the best way of writing down the answer. So that's the working right over here of rates of change. Now, again, another question, and it's more or less along the same pattern. So I'll just set up the integral and let's see how it goes. So first of all, let me get my highlighter ready. The diagram shows the shaded region bounded by the y-axis, the line y is equals to -1, and part of the curve. This is the quadratic curve for x is greater than or equal to -2. So they have drawn this quadratic curve, and it would be going like this, like this, like this, and like this. But they are not interested on this part because over here also there is shaded region. So they're not interested in that. They are just interested in x is greater than or equal to -2. So this is the region that they are interested in. Express y is equals to this thing in the completed square form. Hence, for x is greater than or equal to 2, express x in terms of y. And then hence showing all necessary working, find the volume obtained when the shaded region is rotated through 360 degrees about y-axis. And the first part is completed square. So a beautiful question in which they have combined the concept of quadratics with differentiation. So part 1, we have y is equals to x square plus 4x plus 3. Make sure coefficient of x square is 1, which is the case. Write the first two terms as it is. Write the constant at the very end. First add, then subtract square of half the coefficient of x, that is 2, that is 2. Listen to me once again. Make sure coefficient of x square is 1. If it's not 1, we would have taken common throughout. That's the strategy that I employ. And you have to solve by completing square method. You have to show the process. It says in the syllabus. X square plus 4x, 3 goes at the end. First add, then subtract square of half coefficient of x. Now rewrite the first 3 terms as a perfect square. So therefore, this thing becomes x plus 2 whole square. Simplify the rest. That is -4 plus 3. So therefore, this is x plus 2 whole square minus 1 equals to y. That is the first thing. And then it says, hence, express x in terms of y. So therefore, y plus 1 is equals to x plus 2 whole square. And y plus 1 square root is x plus 2. And x is equals to y plus 1 square root minus 2 plus this thing equals to x. Now, some people they can ask this question, why have I given it a positive sign? Because we are going to the right of turning point. That is the turning point. Or maybe if it's not a turning point, just say so. We know that x squared plus 4x. So dy by dx, let me just prove it to you. That is 2x plus 4. and dy by dx equals to 0. Therefore, 2x plus 4 equals to 0. X is -2. That's the turning point. We also know the turning point from here. This is 1. This is ax minus h whole square plus k. A is positive. That's the shape. And -2 comma -1. That's the coordinate of the turning point, the vertex, the stationary point. Even if the turning point was excluded and we are going forward, when we have the original function is quadratic and we find an expression for x for inverse function, the square root will have a positive sign because we went right of turning point in original quadratic equation. That's the rule. So that's the thing. Now it says, hence showing the necessary working, find the volume obtained. So now, first of all, what are the limits? The limits are -1 to +3. And this is simple area because this shaded region, it's between the curve and the y-axis, and we are rotating like this. So that's the limit. So now what will we do? We will write it like this, that volume, hold for a second, volume equals to pi -1 +3, and this thing over here, x is the subject, that is root y plus 1 minus 2, the whole thing square dy. Now, this is the first time that I'm using WhatsApp at this particular stage. So which question is this? This is question number 13. So let me write over here, question number 13. And the subject, the completing square form, the CSQ form, and then subject X is the subject. And then what else is there? We are talking about volume of revolution. Is this all clear? The question is not over yet. I'm just first sharing this thing so that you can acknowledge, because all the other questions were pretty basic, pretty straightforward, but this is the interesting one. Okay, Ji. So now when we square it, we have to be very, very careful exactly what we are going to do. So this is, let me show you the squaring on the sideline. So let me just remove this on this side. And let me just draw a box for showing the squaring. And let me write over here. This is root y. So this is root y plus 1 minus 2, the whole thing square. And this is y plus 1, the square root disappears, minus 2 into 2, which is 4 root y plus 1. And this becomes plus 4. This is what you get. And how many marks is this worth? It's worth 6 marks. Yes, it's a lot of working. So therefore, this is pi. This is -1. This is +3. This is y plus 1 minus 4. Let me put a bracket over here. 4 y plus 1 raised to power of half. And this becomes 4 between the limits -1 and 3. Now let's double check the mark scheme. This is over here. After the squaring, we have this thing. Let me highlight this. This 4 was there. We need a small one. This 4 was there. And then this 4 times y plus 1 raised to power of half was there. And what else is there? And this is y plus 1 is there. And then you would integrate each term and just what is you're supposed to do. Let me just show you some steps. So first of all, this is pi. Let's start the integration. This is y plus 1 raised to power of, it's already 1. So this becomes 2, this becomes 2, derivative of bracket is 1. 4 as it is, y plus 1, half plus 1 is 3 over 2, division by 3 over 2, derivative of bracket, even if it's an obvious one, write it, and 4 becomes 4y. And this is -1, and this is 3. Let me simplify it further. So this is half y plus 1 whole square. This is 3 over 2. This is -4. Flipping makes it 2/3. This is y plus 1 raised to power of 3 over 2. This is 4y between the limits -1 and 3. So now in red color, I'm plugging in the upper limit. That is 3 plus 1 whole square. Don't forget to multiply by half. This is 4 2s are 8, 8 over 3. This is 3 plus 1 raised to power of 3 over 2. This is 4 times 3. All good, all clear. I'll plug in the pi a little bit later. So let me just remove this and shift it to this side. And then in blue color, let me plug in -1. So this is half -1 plus 1 whole square. This is -8 over 3. -1 plus 1 raised to power of 3 over 2. And this is 4 times -1. Let me draw a bracket. Let me draw a bracket. Let me put a minus sign. Let me put a curly bracket. A curly bracket. There's no space. So let me just be very careful over here. That's a curly bracket. Looks ugly, but accept it right now. So this becomes 0. This becomes 0. This becomes 0. 4 into -1 is -4. And there is a minus sign over here. So this becomes a +4. 4 into 3, that is 12. That's all good. 3 plus 1 is 4. 4 square is 16. 16 divided by 2 is 8. That's an 8 over here. -8 over 3. 3 plus 1 is 4. 4 raised to power of 3 over 2. We just did it earlier. 4 raised to power of 3 over 2. 4 raised to power of half. Raised to power of 3. 2 raised to power of 3, which is 8. So that's 8 right over here. So therefore, this is positive, this is negative, this is positive, that becomes positive. 8 plus 12, 20. 20 plus 4, 24. 24 minus 64 over 3. That is 72 minus 64 over 3. 72 minus 64 is how much? 6 plus 2 is 8. That's 8 over 3, if I'm not mistaken. Yes, it is. And don't forget the pi. Yes, there is a pi. So curly bracket, pi, another bracket, pi, another bracket, pi, and pi over here. That is cubic units. So I think that's enough of practice for integration review second part. And we thoroughly solved questions regarding volume of revolution. Stay tuned for more content. Take care, everyone.